Linear inequalities. Okay, let's first have a look at some properties and then we start solving linear inequalities. So really the properties are almost identical to what we had for equations. That means that we have an addition and subtraction property. Let's give us an example here on the right side that illustrates this. 2x plus 3 is supposed to be less than 7. So what I'm allowed to do here is I can subtract the same quantity from both sides without changing the inequality right here. The left side will still be less than the right side. And I'm going to get 2x is less than 7 minus 3 is 4. All right, so quickly, adding or subtracting the same quantity from both sides is allowed. Now we have positive multiplication. Positive multiplication or division, that is the same thing. I am allowed to theoretically multiply both sides of this inequality right here by 1/2. If I multiply this side by 1/2 and I multiply this side by 1/2, well, this is the same thing as dividing both sides by 2. So what do we get? 2 multiplied by 1/2 is 1. And my inequality still did not change. 4 multiplied by 1/2 is 2. All right. So negative multiplication, now that is something that looks a little bit different. Let's see, if I have, for instance, a negative 3x, which is supposed to be greater than or equal to 6. And if I need to solve this for x, I am supposed to, let's look at it like you used to, we divide both sides by 3, negative 3. Remember, this is the same thing as if I would multiply by negative 1/3. So, what is going to happen right here? What is happening here is the following, that negative 3 divided by negative 3 is x, but my inequality now is switching around. And 6 divided by negative 3, that would be a negative 2. So remember, an inequality switches around when you multiply by a negative number. All right, let's do a few examples after we reviewed how to solve linear inequalities. As I mentioned before, it is really almost the exact same thing as solving linear equations. First, we simplify. Then we are going to collect variable terms on one side and constant terms on the other side. Not quite last. After that, we are going to solve for the variable. This means we multiply or divide by the coefficient. And last, we can express the solution as an interval. And here sometimes graphs can help. So let's go ahead and do one. 5 multiplied by 3 minus x is supposed to be less than or equal to 3x minus 1. So first, simplify. The first thing that I have to do when I write down my problem, I have to simplify the left side, and that means I need to use my distributive property and open up the left side of parentheses. 5 times 3, that is going to give us 15. 5 times a negative x is a negative 5x. This is the end of step 1. Now collecting variable terms on one side and constant terms on the other side. It is easier for us if we just always put the variable terms to the left than to the right. So I am going to subtract 3x from both sides, and I'm going to get 15 minus 8x is less than or equal to negative 1. Now, to move the 15 to the left, to the right, I am subtracting 15 from both sides, and I get a negative 8x is less than or equal to negative 16. All right, and now what I have to do, I solve for the variable. That means I'm going to have to divide by negative 8, and what happens is that this inequality right here is going to switch around. Negative 16 divided by negative 8 is positive 2. So, x has to be greater than 2 in order for my original inequality to be a true statement. I can test this by plugging in numbers that are bigger than or equal to 2 to see whether or not this really holds. Let's sketch the graph of this. So if I would make myself a number line, I would say down here maybe there is 0. This is positive infinity. Down here there is negative infinity. Then let's go ahead and say this is 1 and this is 2. And my numbers are supposed to be greater than or equal to positive 2. Then the graph of something like this looks like this. Down here is positive 2. And all of the numbers that are in this interval greater than positive 2, when I plug them back into this inequality, will turn this into a true statement. So one of the difference between equations, linear equations and linear inequalities is I have more than one solution. And now to write down the solution as an interval, like I said, the graph helps us. The bracket, because it was greater than or equal to, up to positive infinity. Infinity always gets an open parentheses, a round parentheses if you want so. All right, let's do one more. The fractions are bad. Fractions are not all that bad. Don't cry over it. So, there is an easy way to fix this. Fixing means I can turn this really, really quickly into a nice problem. I have denominators, and that means just like with linear equations, I'm going to first find the least common denominator. And between 10, 5, and 10, the least common denominator is 10. So what I'm going to be doing now, I will take this inequality and I simply multiply everything by the least common denominator. This should look like a déjà vu for you because this is the same thing that you did when we were confronted with fractions solving linear equations. It is the exact same trick, if you want to call it a trick. So what I have to do now is parentheses. I have to use distributive property. Everything gets multiplied by positive 10. So if I would write down this step, then I have 10 times 3x over 10 plus 10 times 1 is greater than or equal to 10 times 1/5 minus 10 times x over 10. And now it becomes crystal clear why we multiplied everything by 10. Because look, the things that made us unhappy are going to cancel out. So what I have now is a linear equation without any denominators. Let's collect what we have left. 3x plus 10 times 1, there was no denominator, is greater than or equal to 10 divided by 5 was 2. 2 times 1 is still just 2, minus x. And one more time, right here, we are looking at an inequality like this. This is not as obvious. This one right here makes us happy again. So we are manipulating. We are going from here to there by multiplying with the least common denominator. So let's solve now this inequality that we have now. Let's have a look. Same thing as before. I am moving my variable parts onto one side. 3x plus 1x, that will give us 4x. Now I'm subtracting 10 from both sides. And we are getting 4x is greater than or equal to 2 minus 10. That will be a negative 8. Last thing now, step 3, I believe it was. We solve for the variable, divide by 4. And we get that x has to be greater than or equal to negative 2. Okay. As before, I'm going to express this first as a graph. If 0 is right here, to the left is negative infinity, to the right is positive infinity. So negative 2, negative 1, negative 2 could be somewhere here. And the numbers are supposed to be greater than negative 2. So that means they are going to the right. They are bigger than negative 2. And I am putting a bracket here because of this down there. It was greater than or equal to. The equality was included. Writing this now down as an interval, we will have our solution. The interval, I'm starting at negative 2 and I go to the right. That means infinity, round parentheses, I'm done. Let's do one last one. Solve x minus 4 divided by 2 is supposed to be greater than or equal to x minus 2 over 3 plus 5 over 6. So just like in the last example, we are having fractions. So what is the first thing that we are going to do? Find the LCD. Now in this case, between 2, 3, and 6, it is fairly simple to see that 6 is the least common denominator. So, and I'm exactly as before, I will take my inequality and I will multiply both sides by 6. Everything gets multiplied by 6. So maybe let's write this down one more time. 6 times x minus 4 divided by 2 is greater than or equal to distributive property 6 times x minus 2 divided by 3 plus 6 times 5 over 6. So now a lot of things are going to cancel out. 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 6 is 1. 1 I do not need to write down as an extra factor. All right, I am rewriting now my inequality so that everything looks nice and clean. The better you write down your problem, the less likely you will make any mistakes. 3 times x minus 4 is greater than or equal to 2 times x minus 2 plus 5. All right, always helpful to look back. The same thing happened with this inequality that happened before. We have something that doesn't look nice. It has fractions. We are turning this into an inequality without any fractions by multiplication with the least common denominator. This one down here now is the one that we are going to solve. And we are following the same steps as before. The first thing that I have to do is to simplify both sides. On the left side I have parentheses. On the right side I have parentheses. And that means I need to open them up using the distributive property. 3 times x is 3x. 3 times a negative 4 is a negative 12. 2 times x is 2x. 2 times a negative 2 is a negative 4. I'm still not simplifying because on the right side I have two constants that can be combined as well. I have negative 4 plus 5, that would be positive 1. Now that everything is simplified on the left and the right side, I start moving things from left to right. I take my variable term 2x on the right side and I move it to the left by subtraction. 3x minus 2x, that will be 1x, is greater than, I don't need to write down positive, is greater than or equal to 1. And the last thing to do, we are adding 12 to both sides, and we get that x is supposed to be greater than or equal to positive 13. So I am going to sketch my graph. Let's say this is 0, this is negative infinity, this is positive infinity. Well, 13 would be somewhere on the right side of 0. It doesn't really has to be very accurate. 13 is to the right of 0, and I am now going to look. Greater than means to the right of 13. Greater or equal to means I have a bracket. And I can now write down my solution. The solution is the interval from 13 to positive infinity.